So in this example, we're asked to find the quality of water at a pressure of 1 bar and a specific volume of 0.01 cubic meters per kilogram. Since we're asked to find the quality of the water, that means we're in a saturated liquid vapor mixture state. So I'm going to look at the saturated liquid vapor mixture table for water, organized based on pressure, since I'm given that the pressure is 1 bar, and get the specific volume in the saturated liquid state and the saturated vapor state, and use that information along with this specific volume to calculate the quality. Recall that the specific volume would be like 1 minus the quality times the specific volume in the saturated liquid state plus the quality times the saturated volume, the specific volume in the saturated vapor state. We can rearrange that equation to solve for the quality, and it'll look like this. So in order to find the quality, I need to know the specific volumes. We're given this specific volume, and now I need to find the specific volume in the saturated liquid state and the specific volume in the saturated vapor state. So I'll go to that saturated liquid vapor mixture table for water based on, or organized based on pressure. So let's go ahead and look at that. So here's the table, saturated liquid vapor mixture table for water based on pressure. You can see pressure here. We're at a pressure of 1 bar, so that puts us there. You can see that the corresponding saturation temperature is almost 100 degrees Celsius. 1 bar is about 1 atmosphere. It's very close to 1 atmosphere, so we would expect the saturation temperature to be about 100 degrees C, which it is. So the specific volume for the saturated liquid is given right there, the 0.01432, or 0.00101432, and the specific volume for the saturated vapor state is right there. That's the 1.6939. So we'll remember those numbers. Go back to our original problem. So our original problem is right here. So our specific volume for the saturated liquid state was 1.0432 times 10 to the minus 3 cubic meters per kilogram. And the specific volume for the saturated vapor state was 1.69, I think it was 39 cubic meters per kilogram. And from these, we can now calculate the quality. Quality comes out to be 0.0053. So about a 0.5% quality. So very little of the mass of the substance is in a vapor state for these conditions. It's mostly in a liquid state. If we wanted to sketch this out on, let's say, a PV plot, let me go ahead and sketch this out. Here's our vapor dome. Let's draw an isotherm to go along in here. So here's an isotherm. So we're talking about a pressure of 1 bar. The corresponding isotherm, and I think the temperature was 99.63 degrees Celsius. It's the saturation temperature to go along with that. Here's our saturated liquid specific volume. Here's our saturated vapor specific volume. And our given specific volume is somewhere closer to the liquid side. So we're somewhere right about there. So there we are on a PV diagram. If you want to see it on a TV diagram, it looks very similar. We'll draw our vapor dome. Let's draw an isobar. So this is the pressure of 1 bar. Absolute. Here's our temperature of 99.63 degrees C. Our saturated liquid specific volume, our saturated vapor specific volume, and then our actual state is somewhere right there. It's just a sketch. Okay, we'll end the example there.